Hello and welcome to yet another episode of Burning Questions. My name's Alec, I'm the technical manager at Quelfire, and in this season and this series we have been trying to branch out and talk about different topics in the construction industry focused around fire safety. So we're delighted to have Joe Hart from Delta Fire Engineering join us and hopefully help me and obviously the audience understand a little bit more in areas about fire engineering training. So I'm happy that you've joined us, Joe. Obviously, I've mentioned you from Delta Fire Engineering, but just for the people in the audience, are you able to just like introduce yourself and your company and your role, etc., for us?
Of course. Well, thank you for having me, first of all, to all the guys. What an amazing spot you've got here. My name is Joe Hart. The short answer is I'm a fire engineer, and that's what I'm here as today. So I've been a fire engineer for the last decade here in the UK. I've worked around the world, been really fortunate. My kind of slightly longer job title, I'm Chief Executive Officer of a group of companies. So I founded a fire engineering company about 3 years ago. We've grown now, so I'm CEO of the group and I oversee the fire engineering team at Delta. I'm head of R&D in our research and development arm, and I'm also head of curriculum development in our training business as well. Day to day, I kind of oversee all those businesses, but my passion is fire engineering. I'm very much a working CEO, believe me. So yeah, I'm working on projects as a fire engineer.
Yeah, no, it's good, and that's like I said, the reason why I got you on board, because it's definitely an area I'm interested in, and I find you very knowledgeable. One of the things I did like, and I'll let you expand on it a bit more, is obviously on the Delta website, and that was you had a nice page about your mission and values. Say about joining the industry, but the academia, it's the educational and the knowledge sharing and stuff like that, and just learning. I think that's why you have the research as well as the fire engineering, which is why I've been quite navigated to what you do, not only at Delta, but outside of it as well.
Yeah, I mean, that is the mission, really. The whole reason I set up the business was to improve the industry. It wasn't to make money. It wasn't to build a business. It was to give back to the industry. All the money we've made from the business has gone straight back into it. So
Yeah.
we've built our own research and development lab. We've built a team of people who are aligned. Every decision we make is about safety. It's never about commercial decision. It is always safety of people in buildings.
Yeah.
It's why I spend so much of my time doing things like this. I'm really fortunate, giving back and educating. I'm an academic as well as an engineer, so I teach in a university. I spend a lot of my time giving talks at conferences and events. So the mission really is about making buildings safer and educating people as to how to do that along with us as well. So we give a lot of our expertise and time back to people in our industry and people beyond, collaborating with others, things like this. Yeah, we're really keen. So
Yeah, no,
that sums it really.
really, yeah, again, really appreciate it, and thank you for joining us. And I've honestly, I do feel quite privileged being able to pick your brain as such today as well. So, I suppose what I want to do, sort of like the first half of this conversation, is more focus on your fire engineering day-to-day role, but the academia side, I do want to branch into as well later on. So, from just to help the audience, what sort of projects have you been working on?
Anywhere that we're useful, in truth, is what we work on. Our bread and butter is the built environment. So we work on buildings. We've got high-rise cladding remediation jobs on 20-story buildings. And I've got a 2-bed detached property in Chorley, because we could give advice there that helped the client, and equally in the remediation, we can help people in that building. As well as that, I'm not long after this, I'm on a flight over back to California, back to Los Angeles, where I worked in January on the wildfires. So again, we could bring value to that fire. We could help and benefit. And I'm back out there just in a couple of days' time to go and work there. So our projects are incredibly broad. And something that I am really fortunate, I know, is that I get to pick my own projects, and I get to pick the projects my team work on. So we don't just chase things that we think are good for business. We really, all other things being equal, and we've got 2 jobs in front of us, we'll pick the one where we can add the most value in terms of safety for the people in the building. So there probably isn't a type of building we haven't worked on. We've written fire strategies for ships, we've written fire strategies for submarines, and a 2-bed detached house in Chorley.
Yeah,
We really do cover a bit of everything.
Yeah, I mean, that's quite good. Actually, quite leads really nice, because I was saying the broadness, like you were saying there, I think is really good. So, obviously, being a fire engineer, you've obviously had broad experience, though. I mean, what's today's role of the fire engine in the industry, and the sort of what do you think the limitations are as such?
Yeah, it's a really interesting one, because fire doesn't change. You stick a fire in one building and stick that same fire chemically, and at its first principles, it's doing the same thing. It's doing the same thing if it's in Los Angeles, in the middle of a forest, to if it's in a ship that's moored at Mersey in Liverpool. So fundamentally, the fire doesn't change. But of course, our role does change massively depending on what type of building we're working on and where we're at in the project.
Yeah.
Whenever I talk about fire engineering, I say that fire engineers are fortunate, because we work at every stage or we should work at every stage of the building life cycle. So we would be involved during the design of a project, during its construction. When a building is occupied, we're there checking things like a fire risk assessment and extinguishers and sprinklers and all that. And then when a building comes to be decommissioned or renovated, we're involved as well. So fire is this discipline. And some of my favorite projects are when I've done every stage. I've been involved in the design of a project. I go and see it at handover. I'm there during the occupation. And then, I mean, one of my buildings I've worked on had a fire on Saturday night. So I was there on Monday going to see what went wrong and how we can mitigate it moving forward. So our role really is very fluid, I tend to think, because we can be involved in all those stages. I think what the definition ought to be these days, in terms of what most people think of is design work, it is involved at the very early stage of design.
Yeah.
Because the decisions that we make and we influence will impact the whole design, from how many stairs are in the building, what's the external wall constructed of, what's the structure of the building, right the way down to the nuts and bolts, the very last thing like the fire stopping like we've got behind us. We really do cover each stage and ought to be involved during that process. My least favourite projects are I'm brought in at REBA stage 4 and it's, oh, we need a fire engineer. We sort of forgot about it. And now can you come in and fix everything? Because invariably we can't. So really it's that broad range throughout the construction and design and every stage of the building life cycle.
I agree. Obviously, we try and help out with our way our products are, but yeah, being brought in at REBA stage 5 sometimes and stuff like that is just far too late, because there are certain things, predominantly we do service penetrations, but we have to make changes, and it changes spacings, the coordination, the type, even to the point of the mechanical might want this pipe type, but unfortunately you want 2 hours fire resistance and stuff. There are big changes, so it's good to hear. We're quite an advocate of early engagement here, this side of things. So obviously the main thing, I suppose, what I'm quite interested in, and sorry to put you on the spot, but I know obviously because you've been a lecturer, and that is, what's the topics, the course length? Are you seeing a large number of people coming onto it, that type of thing?
Yeah, I mean, we definitely have a skills shortage in fire across the fire sector, but definitely in my niche area of fire engineering, there is a skills shortage. There's not enough people that are qualified, but also there isn't a defined qualification. So it's difficult to bring the right people in and get them there. Now, the way a degree program is always written, and I've had the benefit of teaching a degree and also writing a degree for an awarding body. So we've done that piece separately for fire engineering. It has to have a mix of both theory and practice. So as a fire engineer, you need to know the fire triangle in lecture 1, but you also need to go out and apply that to fire stopping in a real wall and service penetration. So it is a really, really broad degree program. It is difficult to do.
Yeah.
The one thing that I always caveat and I always say is that a degree program is not a license to practice. You don't get your degree certificate and then immediately get a job and you're an engineer. That's the start, really. I mean, I finished my degree. I then went out to work as an engineer, but I mean, I've said this so many times on things like this, but I learned more in my first 3 months as an engineer working than I did in 3 years of studying. Because there's a big difference between thinking about something and actually doing it. So for me, there's a massive benefit to getting experience as well as studying. So there's different ways into it. And I think the definition of an engineer, fire engineer, is not simply they have a degree and half a year's experience and you call yourself an engineer. That being said, it's difficult to be able to define a competent engineer, because we don't have that clear route in. Now, what makes a good fire engineer for me is a mix of theory and practice. Some of the best fire engineers I know, both in my team and beyond, are people who have come from the sites. So they've come from a practical installation background. They then understand the kind of what real buildings look like, and then you work backwards. Or firefighters equally, because they actually see buildings. They haven't just read about it in a book, and then they underpin that with good theory behind it. The thing also that I have to drop in as well, and I'm certain we'll come on to this, is about CPD.
Yeah.
That you don't kind of get to the point of, oh, I've done my degree, I've done a level 4, level 5, whatever it might be. I've got a license to practice. I'm an engineer now. No one can ever question me.
Yeah.
It's never the case. It's always a case of continuing to learn. I've been an engineer for quite a few years now, but I do more CPD at this stage of my career than I did at the start, because the industry's changing and I need to carve out time to be able to do that CPD.
I like how you brought in that practical side of things, because one of the things we've been quite passionate about, because again, we just work in this office, we design products, we go and test on a fire test furnace, but it's that real life application. So we've been getting lots of feedback of, actually what you've tested is not really practical. You need to, you've not incorporated this, you've not thought, I mean, something as simple as, we've done a 3-sided builder's work opening and forgot about the tiny little gap that's going to be where the deflection hood is because we haven't built it because of the furnace limitations, etc. So
Yeah,
I think you need that blend of practical and theory. You can't just learn everything from a book. So yeah, no, it's good to hear, and that's what I like. So
well, I've just had one to derail the plan completely. Forgive me, Alec, but
yeah, no.
I've just had one in an underground tube station where they've got fire stopping, not dissimilar to what we see behind us and around your facility here. And they built it beautifully and it meets a test standard, but in the test standard, it's not designed under pressure. So as soon as they brought a train in, for the first time, all the fire stopping fell out. And it was a perfect install. It met 2 hours, it met all the requirements and everything. First train comes through, everything falls out the wall because there's no design for it. Now that installation, that use case can only be assessed using an engineering judgment. Because that was, I mean, the exact number was 6 figures. It was certainly over 100 grams worth of fire stopping, just fell out on the first test. And we had to come back. We were brought in to say, what do we do? Because no one's testing that particular standard. So it's a complex thing that moves you away from sometimes what the book says and compliance and into a bit of engineered judgment and into that world, which is where I kind of sit.
Yeah, no, I've said it. I mean, I know everyone thinks you can just have tested solutions for everything, but unfortunately, it's not as easy as that. And I've actually, going back to the thing about the pressures thing, I think that's why there's a big thing around smoke shafts at the moment, the negative pressure, which again, our test standards don't account for. I know there's some have gone out there and done some testing on that, but yeah, it was an area that was never really fought. And I do think that's the problem with, we can test very rigidly to the thing, but there's a lot of grey areas. It's not as simple as black and white as they say. Even to the point where we've been doing some specific testing that we wouldn't publish as general guidance. It's purely for fire engineers. So we've done steel beams through walls where we've included extra stuff because there's no way to have a loaded steel beam through a wall as a fire test, but it happens on site all the time. So we've literally got guidance that's not for the general public. It's purely for fire engineers because we know that application is going to need a fire engineering assessment and you need some primary test evidence to look at and stuff like that. So what's the sort of common challenges you face every day as a fire engineer though, and limitations, I suppose? Obviously mainly in the UK, I know we talked about outside that different countries are different, but the UK, what's the main challenges you're seeing as a fire engineer in today's world?
A high workload across the sector,
Yeah.
But also a high demand for services. So it feeds again into not having enough competent fire engineers. There's a small pool of us and there's a big amount of work to be done. So on projects, we are often under intense pressure to get work out the door. But we can manage that at a business level, and engineer level can look after that. Kind of wider macro problems, I think, is being engaged on problems quite late in the design. So being asked to retrospectively fix things, which is always difficult. And also just having this kind of, we were chatting just before the camera started rolling about this idea of there is a magic wand you can point at a fire engineer and they will fix any problem for you. Unfortunately, there isn't. We're not magicians, and there is a huge expectation of, hey, you're the fire engineer, can you fix it? So that's a big problem we come across because fire in the last few years fire engineering has become a lot more kind of prescriptive, and the Building Safety Act has taken us down that route. So when people want to deviate from that, they think, well, I can just pay this magician to come fix it for me. And sadly, we're not that world. So I do see that on a really high proportion of our projects. We're brought in with a solution given to us to justify, and it moved me away, sadly, from being an engineer a little bit. So huge issue for us, and people I speak to across the sector, across the fire engineering industry, are seeing that same issue come through.
Again, that's one of the reasons I like this show, is to hopefully show everyone that we're all in the same boat together and stuff. So hopefully it is. Are you seeing it improving on projects? Do you think it's just sort of the legacy thing of people were so used to the way it was in the past, they got maybe a lot more easier yeses? Or
so my only metric on is their improvement is, are buildings safer? Buildings are getting safer, I believe. Is my day-to-day improving? No, it isn't. My job is getting harder and harder, but a building's getting safer, yes. So that's a win for me. That's what I care about. The reason for that shift is that it is moving more and more prescriptive. And I got a submission back from the BSR yesterday, and I was looking at it, and I was going, my response was simply, why am I even on this project? You don't need me, guys. You don't need an engineer, because you basically, the BSR and any approver, the approvals world has got more difficult, have come back and they've started to say, don't engineer, just stick to the guidance. So I think my job is disappearing a little bit, because on projects, I'm doing less and less engineering. So my day-to-day is not improving necessarily. I'm doing less and less engineered work, but that's in the interests of making the world safer, which I do care about. Now, that's moving us closer and closer towards guidance. In my view, if we're going that route, we need to make sure that guidance is robust, and there is work to be done there. There is work to be done on making sure that the guidance that we're being made to follow is applicable and robust and kept up to date as well. Because at the moment, I don't know how to design a car park with an electric vehicle in, because there's no guidance. The guidance itself that we're being forced to follow more closely must keep pace with what's happening in the industry and the questions that we're getting asked. So is it improving? Yes, I do believe so. I think that buildings are being remediated. They're being designed with earlier engagement. I think there's more focus. One thing that's certainly happened is focus has sharpened on fire safety, which is a huge shift, because I was working as a fire engineer pre-2017 and post-2017, and there was a massive shift. The kind of work I'm being asked to bid on now, I would never have been asked the question in 2016. It just wouldn't have been engaged to a fire engineer. So there is improvement there. That's a positive we can take.
Yeah, no, it's good to hear. Like I said, I agree with my workload's gone up. I do see the improvement and stuff. But that's a good topic about the guidance, because I think that's another thing that I like that you've highlighted there quite heavily, is the fact that there is quite a heavy reliance on guidance. I mean, for example, approved document B is quoted to me quite daily on a thing. Obviously, it's not the only guidance out there and stuff, but do you feel that there does need to be because I personally think approved document B is good in places, but there is quite significant flaws in it as well. And the reliance on that to the point where so many people out there think that's the regulations and not a guidance document worries me. So I believe there was talks that the BSR was going to be doing a review of all the guidance, etc. I mean, what's your feeling? I mean, obviously you can use it, but there are quite a lot of limitations with the guidance out there at the moment, isn't there?
Yeah, I mean, approved document B as an example is not something I use a huge amount, because I'm an engineer. So day to day, I'm not designing to it. I'm usually using other fire engineer principles, but ADB obviously sits and underpins a lot of what we do. The thing that I would raise is that in approved document B, in the introduction, it says this document applies only to simple buildings.
Yeah.
And it then doesn't define what simple is. And I would present the case that there is no such thing as a simple building. Even a shed can be complex if you use it in the incorrect way. And I wrote a paper years ago, and it's unfortunately the thing that I've become known for somewhat. People quote to me all the time. I wrote a paper called "Does Size Really Matter?" And it was about the height of buildings, and is the height of a building directly proportionate to the risk? And in there, I presented a 10-story residential, student residential, versus a single-story dementia care home. And the answer was that the risk is much higher in that single-story building. It's not only the height, and yet we're bound in approved document B to 18-metre height, 11-metre height, 30-metre height, all those kind of things. Approved document B kind of limits itself and says it applies to simple buildings. Unfortunately, I've seen approved document B used for every type of building going, and a heavy reliance on it.
Yeah.
One of the reasons for that, I think, is because it's easy to read. It's designed to be accessible. You pick it up, you don't need a huge amount of knowledge. You can pick it up and understand it and interpret it. Like I could read approved document A to do with structure and understand it. It's designed for a lay person. So I do see an over-reliance on it. The thing that I really push, and that we were chatting about again earlier, is if you're going to quote a piece of guidance, so you're going to use 18 metres, I firmly believe you should understand where that 18 metres comes from. I think you should find the source. You should follow it. And if you're going to do 45-metre travel distance in a building, or 45, a really good example of it is 45-metre hose lay distances from a dry riser to the most remote point in the block of flats. We design that to 45 metres. If anyone ever presents that to me, I say, where does the 45 come from? And I've got the paper where it comes from on my desktop, because I've studied it and researched it. If I'm going to quote something, I want to know where it comes from. So I really push that with guidance. People have got to understand what the guidance is intending to do, where the numbers come from, these kind of golden numbers as we call them, and be able to interpret and pull them apart a little bit. That's what my whole research group is about.
Yeah, no, it's really good. Actually, it touches a little bit home for us, obviously, because I know there's a lot of contention around it because of the court case fell through and stuff like that. But we're quite near to Crewe with that Crewe care home, so we have to drive past all the devastation and that. And I'm not saying anyone was right or wrong, but the devastation of that building afterwards, to me, the compartmentation was severely lacking, as such as someone who works in passive fire protection. So that was obviously a timber frame care home, but it's not hard at all. And I do think the use of the building needs to be massively taken into account, not necessarily the height. So it's good to hear with that. And going back to, I know we had the conversation before, but I'm a heavy believer of knowing where you've come from helps you move forward as a person. So that's why I've been trying to research things. And like one of the presentations you covered, you mentioned sort of the World War II's, the post-war studies, which I'll be honest, I'd never heard of, but and I've not dived too deeply in it because it's actually a lot larger than I thought when I first heard it. But that sort of obviously going back, we're talking, I don't even know how many years now, we're talking 80 odd years plus, but can you sort of just briefly mention what the World War II, sort of the post-war studies were type thing, and how that sort of led into the world today as such?
Yeah, so I did a series a while ago of talks called the what was it called now? The Influence and Future Scope of the Post-War Building Studies. That was it, and I was given the title. It's not my own. That's why it's not got puns.
Yeah, no puns.
But I did this series of talks. Some of them are on YouTube. You can find them. You mentioned you've watched one of them before, and basically the twist at the end is that we're in the exact same position now as we were post-war, where we've got modern methods of construction and we've got a massive housing crisis. We need to build homes, and that's where we were in 1946 when the post-war building studies were written. And the kind of the gag at the end of it, if you like, or the twist at the end is that there's no such thing as modern methods of construction, because at one point concrete was modern and they called it MMC at the time, and nowadays we call timber modern, but of course in 20 years it'll be something else. So that's the crux of the talk, and as part of that talk, the post-war building studies have floated around academia and industry for donkey's years, literally since the 1940s. And I'd often ask people the question about where does that piece of guidance come from? So where does the 45 metres come from? And people would always say confidently, the post-war building studies. But I'd never met anyone who's ever read them.
Yeah.
Because they're boring and long, and it's just an easy answer. So I thought, well, do you know what? If I'm doing this talk and I'm committed to it, I'm going to read them. So I read the post-war building studies over a long series of weekends and evenings. And they were boring and they were dull. But in amongst there was a load of work that's really critical to what we see today, because that's where you'll find 18-metre heights. That's where you'll find 45-metre travel distance. You find everything in there. And basically what the post-war building studies was, after the Second World War, there was a huge housing crisis in the UK. We needed to build hundreds of thousands of homes. We had to do it quickly. But during the war, they'd converted all the factories to be able to build things quickly. So they started to build out of prefabricated concrete. So suddenly we got high rises, and it was that cultural change that happened that they decided to do this big technical study into how we should better, rebuild Britain post-war. So the post-war building studies cover lots and lots of different aspects of design of buildings. Now, it's no accident that my research group now, we call it the post-Grenfell building studies, because we believe in my group, and everyone that I work with believe we're in the same position now, which is we need to relook at how we design buildings fundamentally and look at lots of different aspects. So the post-war building studies, in this talk I did, I kind of went through each of the bits of guidance. So why is it we use 18 metres on the outside of a building to determine where we'd have 2 stairs instead of 1? Well, it's because in the post-war building studies, it said you could get a firefighting ladder, because firefighting ladders were about 17 metres, plus the metre of you reaching the person. But you must also make sure every room has a window in that's big enough for a firefighter to get in and out of. Now, over the years, we dropped the bit about the window because that was inconvenient, but kept the 18 metres. And I found that really interesting. So I started to really analyse and go through our building regs and all of our guidance and try to find it. And unfortunately, some of the stuff that we design to now is a kind of twisted version of what came from the original source. In some cases, the post-war building studies, in some cases, various other pieces of guidance. A lot of it down to the original NFPA 101, which was the American standards back in 1910, roughly, it was started to be drafted. And it's kind of been mixed and adapted and pulled apart. And it means that when I have a building that is the firefighting access, the appliance has to drive more than 20 metres is one of our golden numbers in the guidance. And if it's over 20 metres, you need to have a hammerhead or a roundabout for the fire service to turn around or whatever. And I've had buildings that are 21 metres driving up to it and it's been rejected. And I've gone, why have you rejected that, just out of interest? And they've gone, because it's over 20 metres. And I've immediately leapt into, what do we think the 20 metres means? Why is that a thing? Why do we care about that golden number? Is it of interest to us anymore, or is it a legacy thing that we cared about 100 years ago? Because you can drive a fire appliance 21 metres backwards, you can reverse it. I could reverse a fire appliance to Scotland if I wanted to. There's nothing stopping you physically and first principles wise from doing it. So a big part of our work as engineers is taking a rule or a piece of guidance, understanding where it comes from and applying it to the real building application that we have. Because I do forget what your question was, Alec, do forgive me, but it was something about approved document B. One of its limitations is you can't write a document that's 100 and something pages long and apply it to every building in Britain.
Yeah.
It's simply impossible. If you wanted to try and write a guidance document for even one type of building, say a hospital, but any hospital, it'd be 1,000 pages long. So a limitation of it is that it is very high level guidance. It's based on precedent rather than science in many cases. And it just simply doesn't apply to every building scenario. You have to design beyond. And that's the role really of a fire engineer.
It's supposed to be there to give you the tools. It's not supposed to be the end result. So, and I like that, I was going to use the word common sense, but as a fire engineer, you've got to look at the application you're looking at, not just as a broad spectrum, and go, actually, yeah, I can justify this because of this reason. Yes, they can easily turn around the thing. The ladder is going to be 20 meters or something. It's understanding the limitations of what was designed. So no, it makes sense. And that's why I always found it interesting, because I didn't know about the ladder thing. That's why when you mentioned it, I thought, but then it made complete sense that actually that's what it was there for and stuff like that. So yeah, no, I appreciate it. And I hope anyone that's watching it will dive into that, because I think, again, knowing where you come from really helps you moving forward. This is the end of part one. We just wanted to draw it a close here, just so you can get the most benefit out of all the topics we've covered so far. So please stick around and join us for part two, which will be coming out shortly.